So yung lesson natin is all about spherical trigonometry. When actually napakalaga ng subject na to sa engineering, lalong-lalo na sa astronomy, sa navigation, yung mga ship natin na naglalayag sa dagat, sa karagatan, ginagamit nila ang application ng spherical trigonometry. Actually, ang spherical trigonometry nahahati yan sa dalawa, right spherical and oblique spherical trigonometry. Katulad din ng nasa plane trigonometry natin na mayroong right triangle and oblique triangles. Dito, ang mga triangles natin, spherical sila. Kaya may tinatawag tayong right spherical triangle and oblique spherical triangle. Kung sa plane trigonometry, yung mga right triangle, ginagamitan natin ng 6 trigonometric functions, ng Pythagorean theorem at ng sum of angle formula. Sa spherical trigonometry, ang right spherical triangle naman, actually, ginagamitan natin yan ng Napier circle at saka ng Napier's rule. And then sa oblique spherical triangle naman, kung sa oblique triangle ng plane trigonometry, meron tayong law of sines and law of cosines. Sa oblique spherical trigonometry, meron din tayong tinatawag na law of sines and law of cosines. Dito, pag-aaralan din natin ang properties ng mga iba't ibang klase ng spherical triangles, mapa-oblique man or right spherical yan. So ito ngayon yung ating tatalakayin within the whole period kahit na hindi natin matapos ang buong subject na spherical trigonometry dahil sa totoo lang pang isang semester yan. Nung kami ang nag-aaral, separate ang spherical trigonometry sa plane trigonometry. Sa prelim and midterm, pinag-aaralan namin is plane trigonometry and then pagdating ng finals, inaaral naman namin is the spherical trigonometry dahil nga sabi ko kanina, lumilitaw yan sa licensure examination ng board exam ng civil engineering. And to start with, ito yung ating spherical trigonometry subject or topic. And let us define it first. Actually, spherical trigonometry is a part of trigonometry which deals with triangles on the sphere. Kung nakakita na kayo ng pakwan ng melon, sigurado lang yan kapag kukuha kayo ng slice. Ang slice na kukuhanin natin, yung balat niyan is in the form of spherical triangle o ina-apply natin ang spherical trigonometry. The object of this subject is to study the relations connecting the sides and angles of spherical triangle. This is of great importance for calculations in astronomy and navigations. So yan yung importance ng spherical trigonometry. So sa mga maritime school, major subject yan, pinag-aaralan talaga ang spherical trigonometry. Now, nagbigay ako ng halimbawa ng isang circle, ng drawing ng isang circle. Dito kasi aaralin natin ang iba't ibang parte ng spherical triangle, okay? Ng ating sphere. Given this circle, and actually spherical yan, no? Yung earth natin, kunwari yan, na-drawing ko. And then within it, magdodrawing ako ng isang circle. Okay? So we call it as the circle 1. And another circle, we call it as the circle 2. And again, another circle, natatawagin naman nating circle 3. May ibig sabihin yung mga drawing na yan. Yung major circle natin, which is actually yung kunwari lang ang ating earth, no? Merong center yan, yung pinaka-center natin. And then, lahat ng mga bilog na nasa loob ng circle natin, ng major circle, from circle 1, circle 2, and circle 3, ang tawag natin sa mga yan, we call them as great circle. Ang great circle, mga anak, kailangan matatawag yan na great circle kapag ang sentro ng bawat circle na nakikita natin nag-coincide lamang sa center ng major circle natin. Pare-pareho lang sila ng center. Okay? So kapag pare-pareho lang ng center ang mga circle natin at nag-coincide sa major circle natin, yung tinatawag nating sphere, ang tawag sa kanila great circle. Okay? At ang diameter ng mga yan, pare-pareho lang. Nagbabago lang ng posisyon ng ating mga bilog. Great circle is a circle whose center coincides with the center of sphere. Kapag nako-coincide sa sentro ng sphere, ibig sabihin ang tawag sa mga yan, great circle. Now, sa great circle na na-drawing natin, we actually have three great circle, no? Ito yung circle 1, circle 2, and circle 3. Lahat ng mga great circles na yan, nag-i-intersect. Katulad halimbawa ng point na to. Yan. So we have point C, this point. Ang nag-intersect dyan is actually circle 2 and circle 3. Circle 3 at saka circle 2. And then, so we have point A, kung saan nakatutok yung letra natin, no? Ang nag-coincide dyan, we have circle 3 and circle 1. Ang nag-intersect, okay? Hindi coincide ang tawag doon. Okay, nag-intersect ang circle 1 and circle 3 at ito yung intersection nila, yung point na yan. And then, again, we have this another point, point B. Ang nag-intersect naman, we have the circle 2 and of course, the circle 1. So, meron tayong tatlong point na nabuo. So, yung tatlong yan, A, B, and C, we actually have already an example of a spherical triangle. So, ito yung ating spherical triangle na nabuo. Yan, ito. So, ito yung ating mga points, point A, point B, and point C. It takes three great circles para makabuo tayo ng spherical triangle. And it takes small circles or three small circles para din makabuo tayo ng spherical triangle or mix ng dalawa, great circle at saka ng small circle. Okay, let's proceed. So, ko-connect natin ang bawat point sa center ng ating sphere. Yan, okay? And then another line connecting the center and the point B. Another line connecting point C and the center of our sphere. Kumbaga, ang shape niyan mga anak, ganito yan. Kumbaga, yan, dodrawing ko lang. At ito yung balat ng, yan. Kapag kumuha ka ng slice ng pakwan, ito yung slice niya. Ang tawag dito, anak, sa balat, ang tawag diyan, we call it as dalyon. Yung ugis spherical triangle. And then yung laman, ang tawag diyan, wedge. Tandaan nyo lagi, no? Ang tawag sa laman, wedge ng pakwan. Anyway, burahin ko na, no? Total, naisulat ko na in the recorded naman para maayos yung ating diskusyon at yung ating drawing. Okay, next. Okay, ang tawag dyan, we call it as the wedge. And then yung balat naman, we call it as dalyon. And then, not only that, yung mga point na yan, ito yung ating angle C, ito yung point B na tawagin nating angle B, doon sa portion ng lyon. Ito naman yung angle A. Okay? And then this is side B, side A, and side C. Take note, sa spherical trigonometry, ang measurement natin sa lahat, mapa-side man, mapa-angle man, laging naka-degrees. Okay? Ang side A, side B, and side C can be measured by degrees. Angle A, angle B, and angle C can also be measured by degrees. Lagi tayong degree measurement dyan. Now, yan yung sample ng ating yun, yung balat. Kapag kumuha ka ng slice ng sphere natin, so ito yung ating spherical triangle. So we have angle A or alpha, angle B or angle beta, and angle C. And then, yan yung katumbas niyang symbol ng angle C natin. So ang tawag sa balat, again, I repeat, we call it as the lune. So yan, sample ng Earth natin. Kunwari, naglalakbay ka from here, point B hanggang point A, or from point A doon sa taas. We have point C in a form of spherical triangle. Naglalakbay ka, hindi mo pala alam ng direction mo, yung mabubuo mong form is nakaspherical siya. Spherical yung shape. Okay, let's proceed. Yan yung ating spherical triangle ngayon na ating na-isolate sa ating mga figures. So we have angle A, angle B, and angle C, and then the rest are all sides. Now, para mas maintindihan ninyo yung ibig sabihin ng great circle, again I repeat, ang tatlong great circle, with their intersections, we can actually form spherical triangle. Okay, let's proceed. So, etong ibig sabihin ng great circles. Isa-isayin natin. Great circle is a circle whose center coincides with the center of the sphere. Kapag nako-coincide ang center ng isang bilog sa sentro ng sphere, piyado great circle yan. The closest analog to straight lines is great circle. Okay, so let me correct this. This is great circles. It is a circle on the surface of a sphere that has the same diameter as the sphere. So kung ano yung diameter ng great circle natin, dapat yun din ang diameter ng ating sphere or else hindi yan great circle. Dividing the sphere into two equal parts, you will have a hemisphere. Kapag yung sphere, inati natin into two equal parts, hemisphere ang tawag dyan. Parang bowl or silyo sa Kapampangan, yung lalagyan natin ng ulam sa kusina. It is the interaction of a sphere with a plane going through its center. And then, the largest circle that can be drawn on a given sphere. Yan na yung pinakamalaking circle na pwede mong madrawing sa loob ng isang sphere. Wala nang lalaki pa dyan. And then, hindi pwedeng lumiit yan. So, yan ang tinatawag nating great circle. Meridians and equator of the Earth are both examples of great circle. Yung Earth natin, may equator yan, and then at the same time, may meridian. Lahat ng mga yan, puro halimbawa ng great circles. Any questions so far regarding about the definition of great circles? Wala ba kayong gustong itanong bago tayo magpatuloy sa ating diskusyon? Wala ba? Wala bang ibig itanong about great circles? Okay?
Wala pa naman po, sir.
Okay, so let's proceed. So may importance ang great
Wala po.
circle sa measurement Mamaya connected yan sa North Pole and South Pole na pag-uusapan natin mamaya. Great circle again. Great circle paths are used by ships and aircrafts where currents and winds are not significant factors. Sa paglalayag, ginagamit ang great circles. Connected yan sa paghahanap ng value ng distance from a point to another point. So we use the great circles. For aircrafts traveling between continents in the northern hemisphere, these paths will extend northward, near or into the Arctic region, while easterly flights will often fly more southerly track to take advantage of the jet stream. So yun ang discussion natin regarding about great circle. And not only that, hindi lang great circle ang ating tatalakayin. Kung may great circle, definitely meron din tayong small circle. Definitely yan yung mga circle na hindi nagko-coincide sa center ng sphere. A small circle of the sphere is a circle constructed by a plane crossing the sphere but not in its center. Anywhere, basta wag lang sentro, small circle ang tawag dyan. If I will draw again a circle or a sphere, at ito yung center ng ating sphere, natural magdodrawing ako ng circle sa taas. Yung center niya, hindi rin yung sentro ng sphere. So this is a small circle example. Another small circle sa ibaba naman ng center natin. Okay? Ang tawag sa dalawang yan, we call them as small circles for as long as na yung center ng mga circle natin hindi nako-coincide sa center ng sphere. Small circle ang tawag sa mga yan. May kaibahan kasi ang pagsosolve ng distance between the North Pole and the small circle at saka ng great circle sa North Pole. Okay, may malaking kaibahan yung dalawang yan mamaya. What is a pole? A line through the center of a sphere perpendicular to the plane of a circle on the sphere cuts the sphere into 2 points called the poles. Actually, may dalawang pole tayo. We have the North Pole and the South Pole. Saan ba yung position ng mga yan, no? So, eto muna yung sphere natin and then nag-drawing ako ng great circle. And this great circle actually coincide with the center of our sphere. So, ito yung center ng ating sphere. And at the top, yung point na yan, yan ang ating North Pole. Sa baba naman, ito yung ating South Pole. So, ang tawag sa dalawang yan, we call them as poles. We have the North Pole and the South Pole. But usually, when we calculate distances or angles, ang reference point natin lagi is the North Pole, yung nasa taas. Mamaya makikita ninyo. What is then a polar distance? The least distance on a sphere from a point on the center to its pole. The polar distance of great circle is always 90 degrees. Kapag great circle yan, ang polar distance natin is definitely laging 90 degrees. Okay, let's do it. We have the center of our circle, and this is it. And then we have this great circle, okay, na nako-coincide yung center niya rin sa center ng sphere. And then, we have another circle, but we call it as the small circle. Yung center ng small circle, hindi na nagko-coincide sa great circle natin. And then, let me place the North Pole. Okay? And then, the South Pole. From North Pole, okay, ito yung pole natin, no? And then, we have another pole. Okay? And then, the center of our sphere. Also, the center of our great circle. Now, ito yung pag-uusapan natin. From this point sa North Pole hanggang sa point ng edge ng ating circle, ng ating great circle, ang distansya, ang angle natin, P sub 2 is 90 degrees. Katulad ng nabanggit dito kanina, the polar distance of a great circle is always 90 degrees. Now, let's talk about the pole and the small circle from here hanggang doon. Yan, yung surface na yan. Ano yung layo ng small circle sa North Pole? Let us assume that it is P sub 1. Okay? Also in degrees. Pero hindi yan haabot ng 90 degrees. Definitely less than 90 degrees ang measurement ng ating P sub 1. At yun ang ating polar distance. Spherical wedges and lunes. Two diametral planes that form an angle divided the sphere into 4 equal wedges. Opposite wedges being congruent. So this is congruent. Let me insert letter G. The surface of the wedges are called spherical lunes or digons. Ang ibang tawag sa lunes, digons. Okay? Spherical lunes or digons. Or ito yung balat ng pakwan kapag kumuha ka ng slice nito. And then, yung balat, malamang ang formation na makukuha natin is oblique spherical triangle or right spherical triangle. Depende sa pagkaka-slice ng pakwan. Now, spherical triangle consists of three arcs of great circle. Yung binabanggit ko kanina, no? I repeat, spherical triangle consists of three arcs of great circles that form the boundaries of a portion of a spherical surface. Tandaan nyo lagi yan. Now, we also have the properties of spherical triangles. Una, pakibasa nga, Jeline, yung properties ng spherical triangles, yung una natin. Okay? Jeline? Pakibasa nga yung letter A.
The
Oh,
magnitude of... Di po ako narinig, sir.
sige na. Okay na anak. Okay. Sige, basahin mo na. Hello? Hello, hello? Okay, continue anak.
The magnitude of the side of a spherical triangle is the angle subtended by it at the center of the sphere and is expressed in degrees and minutes of arc.
Okay, so we're pertaining to the arc. Okay, I repeat. The magnitude of the side of spherical triangle is the angle subtended by it at the center of the sphere and is expressed in degrees and minutes of arc. So, yun yung tinatawag nating also na length of an arc. Okay? And then, for the second one, pakibasa nga, Oliver. Pangalawang properties ng spherical triangle yan, Oliver anak. Pakibasa nga. Anong nakasaad? Isa pang properties ng spherical triangle.
Maximum value of the side.
Okay, mukhang may inay internet, ano?
The maximum value of a side. The maximum value of a side of a spherical triangle is 180
Okay, that's true.
degrees.
Hindi tayo pwedeng lumampas ng 180, pero pwedeng hanggang 180 lang. Okay? The maximum value of a side of a spherical triangle is 180. Yung isang side ng spherical, hindi tayo pwedeng lumampas ng 180. Ang maximum lang, 180 degrees. Yung side. Okay, we're pertaining to the side. Remember that. C, the maximum value of an angle of a spherical triangle is also 180. 180 degrees and hindi tayo pwedeng mag-exceed dyan. Yan yung pangalong property ng spherical triangle. Tandaan ninyo yung mga rules na yan. Okay, pangapat. The sum of the three sides of a spherical triangle is less than 360. Kapag pinagad yung tatlong side ng spherical triangle, dapat mas maliit sa 360 degrees. Halimbawa, yung side A, side B, and side C, kapag ginad natin lahat ng angle, dapat less than 360. Or else, hindi yan spherical triangle. Hindi tayo makakabuo ng spherical triangle kapag na-violate ang rule na yan. And then letter E, the sum of the three angles of a spherical triangle is any value between two right angle and six right angles. So dapat ang value ng sum ng three angles of a spherical triangle is between 180 and 540. So hindi pwedeng maliit sa 180, hindi naman pwedeng mataas sa 540. Dapat nasasaklaw lang between 180 degrees and 540 degrees ang sum ng tatlong angles. Or else, hindi mo pwedeng tawaging spherical triangle ang mabubuo natin. Kasi nga, na-violate ang rule na yan, ang property na yan. And then, coming up next, the sum of any two sides of a spherical triangle is greater than the third. Okay? Halimbawa, side A and side B, i-add natin. kailangan ang total nila lamang sa side C. Hindi pwedeng mas mababa sa side C. O ibayin natin, halimbawa ang side B at ang side C in-add natin, kailangan ang total nila lamang sa side A. Or another way, ang side A at side C i-add natin, ang makukuha nating angle dapat lamang sa side B. So, ayun yung mga properties natin. And then, for the last one, the greater side as the greater angle opposite to it. Tandaan nyo lagi yan. The greater side as the greater angle opposite to it. Next. And for the last property, if two sides of a spherical triangle are equal, the angles opposite to them are also equal to each other. If two sides of a spherical triangle are equal, the angles opposite to them are also equal to each other. Definitely, equal lang ang side nila. Definitely, ang mga opposite angles nila, equal din. Parang sa plane trigonometry din yan. Ibig sabihin, meron tayong isosceles kasi equal yung two sides at saka yung dalawang angle. Sa plane trigonometry yan, ano? Okay, let's proceed. Spherical triangle again. Ang spherical triangle nahati yan sa dalawa. The right spherical triangle and the oblique spherical triangle. So iba yung mga tools na gagamitin natin sa right spherical triangle and then magkaiba naman pagdating sa oblique spherical triangle. Now, let's talk about the oblique spherical triangle first. Sa spherical triangle na oblique, ang ginagamit nating tool ay ang tinatawag nating law of sine. At ito yung ating law of sine. The sine of side A all over sine of angle A is also equal to sine of side B all over sine of angle B, also equal to sine of side C all over sine of angle C. Alisin ko lang yung letter A, no? So, hindi kasama yung letter A dito. Yan. So, sine of side C all over sine of angle C. Sa plane trigonometry, yung side hindi naka-sine. Pero sa spherical trigonometry, pati yung mga side naka-sine. Naka-function na sine. Okay? Nagigets ba ninyo yung kaibahan ng law of sine sa plane trigonometry, sa spherical trigonometry? Mamaya gagamitin na natin yung mga yan. Nagigets ba ninyo? Hello? Mahina ba yung signal ninyo?
Yes, pa.
Okay, anyway, naka-record naman yan. Then we also have the law of cosine for sides and ito yung ating mga formula. The cosine of side A is equal to cosine of side B times cosine of side C plus sine of side B. Sine of side C, cosine of angle A. And isa lang yung pattern nila kapag ginanap naman natin ang value ng side B. Cosine B is equals to cosine A cosine C plus sine A sine C cosine of angle B. And then cosine of side C is equal to cosine of side A cosine of side B plus sine of side A sine of side B times cosine of angle C. So yun yung ating law of cosine for sides. Parang sa plane trigonometry din. And then, kung meron tayong law of cosine for sides, meron din tayong law of cosine for angles. And ito yung ating mga formula. So may pattern pa rin. Cosine of angle A is equals to negative cosine of B cosine of C plus sine of B sine of C cosine of side A. Hanggang umabot tayo ng cosine of angle C sa pinakaibaba. Halos pare-pareho lang ang mga... Hello? Hello, hello. Okay, let's proceed. Hello mga anak, nandiyan pa ba kayo? Medyo naantala yung ating recording ng discussion natin. Hello, hello. Still there? Still there ba, anak? Mga anak? Hello, hello? Hello, hello, hello?
Opo, sir. Nandito pa po.
Putol-putol yung ano natin. Ano kayang nangyari? Ba't kaya nakaganon? Okay, open ko ulit, no? Balik natin sa dati. Ilang minuto na lang tayo? Ilan na lang? May nakalitaw bang time sa ating discussion?
Kulang na lang pong 2 minutes.
So siguro i-open na lang natin uli, no, anak, no, para ituloy natin yung discussion natin. Ilip ko dito and then share kayo uli. Open niyo uli yung link para matapos natin yung discussion natin.